Both of these are following up on yesterday's lesson. So first of all, when we see expand, it tells us to distribute. So I'm going to multiply that 10x to the 6th by x to the 7th first. So the 10 is going to stay at 10 there because there's nothing that's going to change the 10. There's no number in front of the x to the 7th. And then I multiply x to the 6th times x to the 7th, which remember means multiply the x's, so add the exponents. 6 plus 7 is 13. So that's our first one. Then I multiply the 10x to the 6th by 36x. Now in this case, I'm multiplying 10 by 36. Anytime you multiply a number by 10, it means just add a 0 to it. So 36 times 10 is 360. And then I'm going to do the x to the 6th times x. Remember that x is x to the 1. So I do the 6 plus the 1. So that gives me x to the 7th.
So good so far.
And then minus, and then I now do the 10 times the 37. That gives me 370, because again I just have to add a 0 on to multiply by 10. And then the x to the 6th, there's no x's in that last term, changing it so it stays x to the 6th. And then for the second problem, our factoring problem, it's doing the exact same thing as what we just did, except that it's going in reverse. It's going from something without the parentheses to something that does have all the parentheses into it. So in order to factor that, I first look at each of the numbers, 12, 36, and 60. What can I divide all three of those by?
6.
6.
12.
So I'm going to start by writing a 6 out front.
You also do it by 12. Yeah.
All right, and then we look at the x's. Okay, so x to the 8th, x cubed, and x. Can I pull x's out of every term? Yes.
Yes.
But since this is just an x, I can only pull one x out. So I'm going to actually divide out 6x. Let's do that. So I do the 12x to the 8th divided by 6x. 12 divided by 6 is 2. X to the 8th divided by x is x to the 7th, because we subtract the exponents when we divide. All right, the minus is still there. Now I do 36 divided by 6, which is 6. And x cubed divided by x is x squared. Then minus 60 divided by 6 is 10. And then x divided by x is just 1, so that goes away. All right, and then to double check ourselves, we look at the stuff that's inside the parentheses. Is there anything else I could divide out of every term?
Those 2.
Yes, notice they're all divisible by 2, which means that actually there was something bigger than the 6 I could have pulled out at the start. So what do you do when that happens?
Just leave it.
I still need to factor that 2 out. Now, when I do that, it's like I have 6x times the 2 that I factor out times all that stuff. Now, when I do 6x times 2, what's that equal? 12x. And so notice when I pull that 2 out, I don't do 6 plus 2, I do 6 times 2. So then it becomes a 12x outside. And now to get there, I know I'm just dividing what I had in the parentheses in the last step by 2. So let's go ahead and divide those by 2. It gives me x to the 7th minus 3x squared minus 5. And then again, we do want to still double check ourselves. Is there anything else I can divide out of every term?
No.
Nope. So that tells me that is the completely factored form. Because I'm always looking to factor it completely. That is, factor out the biggest thing that I can until it can't be factored anymore. So, final answer. And of course, yes, you could have gone straight to this if you had seen the 12 divides out at the start. So, for our next problem here, we're going to be looking at these types of problems today. So please write this down. Expand x plus 5 times x plus 4. Now notice what we're multiplying here. We are actually multiplying two binomials, specifically two linear binomials here at the start. We'll do nonlinear binomials later as well. But again, remember that vocabulary that we had talked about earlier. Binomials are those polynomials that have two terms. And so notice that one has two terms and this one has two terms. So that's why we describe this as multiplying binomials. All right, now in order to multiply these out, we are going to multiply the first parenthesis by the second parenthesis, basically by everything in it. It's distributive property, it's just like souped up. Because like, I have to multiply this x plus 5 by x and by 4. Now you don't need to write it out quite yet. I just want to kind of explain why we do what we do first. which means that we're going to be doing the x plus 5 times x, and then plus we have to do the x plus 5 times 4. This is distributed properly like we've seen it before, but that x plus 5, it looks really ugly, right? And so then we end up having to distribute again. So I end up multiplying the x into both of those and the 4 into both of those. Notice the upshot though, and this is the way we're going to simplify this process down, is basically I end up multiplying everything in the first parentheses by everything in the second parentheses. And the nice part is that by remembering it that way, you're going to see that it actually not only works when we multiply binomials like this, but it's actually going to work no matter how many terms are inside each parenthesis. So now we can actually look at doing that. Just clear out some space. So if I'm multiplying everything in the first parenthesis by everything in the second, I'm actually going to draw little arcs showing what gets multiplied by what at each step. That way I can make sure I got everything. So first I'm doing x times x. What is x times x?
X squared.
X squared. Great. Next up, I'm going to multiply x times 4. What is x times 4?
4x.
4x, that's it. All right. Now I do it with the 5. What is 5 times x? 5x. Notice it's positive, that's why I say plus 5x. And then finally I do the 5 times the 4. What's 5 times 4?
20.
20. And so that's what we get in our first line of work. There's actually going to be 2 lines that we show total here. The reason why there's 2 lines total is because you'll notice that we have like terms here. We have 2 of them that just have x's. So after I multiply them all out, and by the way, notice if I multiply 2 things by 2 things, I get 4 things. Yeah. So you should be getting that as expected. And just you check your work at that point and see if something can be combined. In this case we can. So I'm going to add those together. Notice then, that means that the x squared stays the same. Now what is 4x plus 5x going to give us?
9x.
9x, yeah. And remember that they have to be like terms because they stay the same. They have to both be x's because it stays x. I don't change any exponent on the x when I add them. And then the plus 2, it just stays a plus 2 as well because there were no like terms with it. I meant that to be a 20. I think I left that off or erased it at some point. There we go. The 20 stays a 20, and there's your final answer. So basically you multiply it all out, and then combine the like terms where you can. And now to practice this idea, we're just going to keep with it. So here's 2 more problems. Use the same method. Please multiply both of these out. That is, expand them. So what makes these especially different from the first example that we did is we do have some minuses in here this time. So let's see how we deal with those. So again, I'm still going to be drawing those out. So I'm going to do the x times the x. Of course, that's still x squared. And then I do the x times the 8. It's 8x. Now, I'm going to switch colors here. Now I'm going to actually multiply these 2. Now what I'm actually multiplying there is negative 1 times x. So I treat that minus 1 as a negative 1. So negative 1 times x gives me a negative x. Now you have 2 options at this point. You could write
Negative 1x.
plus a negative 1x. Or we could clean that up a little bit. And I always like to clean them up as much as I can because we don't need more stuff in our expression. It just ends up being clutter. So do I really have to write the 1?
No.
No. And do I really have to write plus a negative? No, because plus a negative is the same thing as minus. And so I'm going to write that as minus x. That looks a lot cleaner to look at. Now it means the same thing, so if you want to write it the other way at first, you can. It's just in the next step it's going to have to be cleaned up. And then having done that, I now multiply the negative 1 times the 8. Negative 1 times 8 is a negative 8, so again I'm going to write that as minus 8. And then we look to see if there's any like terms I can combine, and yes, there are. I'm going to be able to combine this positive 8x with the negative 1 8x, or negative x. So in other words, I'm doing 8 minus 1. So the x squared stays the same. 8 minus 1 gives me a positive 7, so it's plus 7x. And then the minus 8, it was unaffected, so it stays a minus 8. Now on to the second one. We're doing the same basic process. So I start by doing x times x, which gives me x squared. Then x times what there?
-2.
That's x times -2, yes. We need to treat that as a -2 when we see that -2. So x times -2 gives me a minus 2x. Now I repeat that from the -6. So -6 times x gives me -6x. And then -6 times -2 gives me what?
-12.
A negative times a negative is a positive. So it gives me positive 12.
Oh.
All right, and then again we look to see, are there any like terms that I can combine?
Yeah.
And yes, there are here. It's those middle two terms yet again. And so it ends up being a -2 minus 6, which is -8.
-8x.
So it's x squared minus 8x plus 12. Notice there wasn't anything I could combine with the plus 12, so that's why I just stayed at plus 12. All right, so factoring these two, or expanding these two rather, these are going to be following the exact same rules as what we used before. Just I'm throwing in some extra stuff so that we have to really think and make sure that we're using the right process here. So I'm going to multiply everything in the first parenthesis by everything in the second. So first up, 5x times 2x. 5 times 2 gives me 10, and x times x gives me x squared. So that's 5x times 2x. Now I do the 5x times the 5. That's going to give me 25x. Now I do it with the 3 all over again. So now I do 3 times 2x. That's going to give me a 6x. And then I do the 3 times the 5. So that gives me 15. All right, now we look for like terms, and yes, we do have some like terms in this case. Again, it's those x terms in the middle. And so the 10x squared stays the same. 25x plus 6x, if I add those together, I get a positive 31x. And then the 15, it didn't have any like terms, so it stayed to 15. So that's your final answer for the first. All right, now on to the second problem. And again, our process is going to be the same kind of thing. So I'm going to multiply x to the fourth by x cubed. X to the fourth times x cubed, remember that when we multiply the x's, I add their exponents. So that ends up giving me x to the seventh. Now I have to do the x to the fourth times -1. Well, that would give me -1 x to the fourth. I don't really want to have to write the 1 there, so I'm just going to write negative x to the fourth. If you wrote the 1 in front of it, it's still technically correct, but again, we're just trying to write it as cleanly as possible whenever we can. All right, now we repeat the process, multiplying everything now through by the 7. So 7 times x cubed is going to give me 7x cubed. And then the 7 times the -1, it's going to give me a -7, because remember, we're multiplying those two together. And then again, we look to see for any like terms that I can combine. Are there any like terms I can combine here?
Nope.
No, not in this case. So that means that one's done. And so that is now your final answer.